In this video, we will look into factoring. So factoring by greatest common. Okay, factoring by greatest common factor. So normally when we say factor, meaning we are pulling out something. Whenever we do factor, meaning we are pulling out something. Okay? So always remember, whenever we do factor, meaning we are pulling out something. Okay, so let's have an example. So let's say we want to get the factor of 3x plus 6. So for us to get the factor of 3x plus 6, we have to examine each term, wherein we have to think of a number that when divided by 3 and divided by 6, we will get whole number. Okay? What number can we divide by 3 that can be also divided by 6? So 2, we cannot divide 3 by 2 because it will have a remainder, but 6, we can divide 6 by 2. Okay, so meaning since 2 cannot be divided by 3, we cannot use 2, but 3 divided by 3 will give us 1, and 6 divided by 3 will give us 2. So I guess that is our factor for this example. So we'll pull out 3 out of this expression, so this will become 3, and then what number or what letter should we multiply with 3 so that we'll get x? So we will multiply 3 so that we can get 3x. So 3 times x is 3x. Then we have a plus sign here, and then what number should we multiply to 3 so that we will get 6? Okay, obviously that is 2. So this is now the factor of 3x plus 2. So if you are going to distribute this to the term inside of the parenthesis, 3 times x, it will give us 3x, and then 3 times 2, it will give us 6. So there you go. That is now our first example. So let's take another example. Let's say we have xy minus xz. So what is the common for both terms? X. So meaning we have to pull out x. So x, and then what letter should we multiply with x so that we can have this result, x times y? Because we have to write there y, and then we have a negative here, and then we have z. So there you go. So x times y, we will get xy. X times negative z, we will get negative xz. Okay, let's have another example. This time let's try t cubed plus 2t squared. Okay, so we need to think of similar terms here. So what are the terms that are similar to both sides? So there is t. We have t and we have t. And the second move will be, let's try getting the highest value, the greatest number, because we are trying to factor this by using greatest common factor. So what is the highest number that can we get from t cube and t3? So let's try t3. So if you're going to put t3 here and then multiply to something, let's say 1, so that we will get still t3 plus 2 and then t. So this will be incorrect. Why? Okay, for the first part, t times 1 will get t3, but for this part, t times 2t, this will become t3 plus 2t to the 4th power. So that is no longer equal. This equation here, or this expression here, is no longer equal to this expression here. So meaning this is incorrect. So t square is not common for both terms. So let's try, t cube. T cube is not common to both terms. So let's try t square. Okay, t square. So what number should we multiply to t square so that we'll be able to get t cube? Of course, that is t. T square times t. So just add the exponent. We have an invisible one here. 2 plus 1, that is 3. And just copy the t. Okay. And then the plus sign, because we have a plus sign here. And then we will just write 2. Okay, because t square times 2 will give us 2t square. Okay, there you go. Then let's have another example. Let's say x4 x square. Okay, so both terms are similar because we have x. Now the next step will be to identify the highest number that can we pull out from this expression. So maybe we can pull x squared. So let's try x squared. So what exponent of x should we add here so that we can get x4? So let's add here x squared. So because x times x squared times x squared will give us x to the 4th power minus 1. Because x squared times negative 1 will give us negative x squared. Okay, there you go. Let's have another example. This will be our last example. So let's say we have 12r square plus 9r square s square. Okay, so we have 3 terms here: the first term, second term, and the third term. So let's identify the number which are similar to each terms. So each term has a coefficient. So the first term has 12, the second term has 3, and the third term has 9. So all the terms have their coefficient. All right, so now let's identify what are the greatest common number for all the terms. Okay, so maybe 3, because 3 is a factor of 12 and also a factor of 9. So we can get 3 here. So this is equals to 3 Then followed by, what is the common? Again, for all the terms. So we have r. We have r here. We have another r here. And then another r here. So we know that all terms have r. The next step will be to think of the greatest common factor. So we cannot use r squared because we have a lesser value here, an r with no exponent, so maybe we can get this one, r. Okay, the next move will be to identify the next common letters for all the terms. So we have s, but for our first term we don't have s, so I guess we will stop here. So next is, what is the number that when multiplied by 3 we will get 12r squared? So I guess 4, no? 4r, because 3r times 4r will give us 12r squared. And then minus 3r, we already have 3r, so we will just add s here, because 3r times negative s will give us negative 3rs. And then plus, so what number should we multiply with 3 so that we'll be able to get 9? Okay, so we have 3 here because 3 times 3 is 9. Okay, 3 times 3 is 9. And then r times r should be r squared. So let's add r here, and then we'll just copy the s squared. So there you go, that is now our answer. So factoring, we are pulling out the greatest number. Okay, so let's examine again. 3r times 4r, we get 12r squared. And then 3r times negative s will give us 3rs. And then 3r times 3r squared will give us 9r squared s squared. Okay, so in this video, let's have a different example of factoring. So let's say we have negative a minus b. Okay. So if you're going to observe this expression, it will tell you that there's no way to factor this out. But there is. So what is the factor of this? We will use the negative 1. Negative 1 times a, it will give us negative a. And what sign should we use here so that we'll be able to get negative? So we'll use positive here and then b. So that is now the factor of negative a minus b. So let's examine. Negative 1 times a, it will give us negative a. Negative 1 times positive b, it will give us negative b. So there you go. Another example, let's say 2x plus 5y. Again, if you look at this expression, it looks like there is no factor. But by using negative 1, there is a factor. Again, negative 1. And then, what number should we multiply to negative 1 so that we will have negative 2x? You're correct. So we have positive 2x. So what number should we multiply to negative 1 so that we will have positive 5y? Yes, you're correct. It should be negative 5y. So let's examine. Negative 1 times 2x, it will give us negative 2x. Negative 1 times negative 5y, it will give us positive 5y. Okay, let's answer another problem. So this time let's try negative 3x squared times y minus 6xy squared. Okay, so let's solve the factor of this. Let's try getting the factor of this expression. Okay. Okay, what is the common number for each term? So we have 3, we have coefficient here, and we know that 3 are both factor of each term, of each coefficient, so that's why we are going to write here 3. And then both of these have x and both of these have y. So let's use here 3x because that is the greatest that can we pull out from this equation. I mean from this expression. Okay. And then what number should we multiply 3xy so that we will get negative 3x squared times y. I'm sorry, you should have a negative here. So maybe we can use 1. Okay? Or I mean not 1. Instead, we will use x. Okay? Because negative, let me fix this one. It should be negative 3x. Okay? Negative 3xy times x, it will give us 3x squared y. Okay? Plus, because negative times positive is negative. Okay? Negative times positive is negative. Okay, so what number should we multiply to negative 3 so that we will get negative 6? You're correct. It's 2. Negative 3 times positive 2 will give us negative 6. And then we have already x here, so we don't need to add x here anymore, but we have 2 y's, no? 2 y's. So the meaning of y squared is we have y times y. So we have 2 y's, no? For this case. So we need to add 1 y because the other y is already available outside the parentheses. So negative 3xy times positive 2y is negative 6x, then y times y squared. There you go. This is now the factor of our equation, expression. Okay, let's have another example. This time let's try negative 4 a square b cube plus 12 a cube b square. Okay, so what is the common for both terms in terms of coefficient? We know that 4 is a factor of 12, so we can use 4. So let's write here negative 4. Then both terms have this a, and both terms are also b, have this letter b. Okay, so let's start with a. We can get a square here because that is the highest, and we can get b square here because both of these terms has b, no? And then what numbers can we multiply to negative 4 so that we'll have a result of negative 4a squared b squared? So just add here 1. Okay, then minus, why minus? Because negative times negative will enable us to get positive. Okay, 3 because 4 times 3 is 12. Then we'll add a here because a square times a will give us a cube. And let's add here b because b square times b, we no longer need to add b here. Okay, because we already have b square here. B square, b square. Okay, there you go. This is not the answer.